This is all about Avogadro's number and the mole and how to apply it. So what is the mole? So 1 mole is just equivalent to 6.02 times 10 to the 23 atoms. So if we look at this cartoon container here, we can say that if there is 6.02 times 10 to the 23 atoms of a specific substance, for example, an element or a compound in this container, we can say that there is 1 mole of that substance in the container. So this is the formula that we're going to use. So the first N, big N, stands for the total number of particles. Little n denotes the number of mole, and that's how you write it in short form. And Na stands for Avogadro's constant, or 6.02 times 10 to the 23. So the first question is, if a container holds 4 mole of gold, how many particles of gold are in the container? We first write down what we know. So little n is the amount of mole, so in this case it's 4 mole, and Na is Avogadro's constant, which is always 6.02 times 10 to the 23. Then we write down our formula and substitute all the numbers that we know. So we know that little n equals 4, so we put that in, and Avogadro's number is 6.02 times 10 to the 23. We work that out and get 2.408 times 10 to the 24. And that's the number of particles. Second question. If there are 1.204 times 10 to the 24 particles of sodium in a container, how much mole is there in the container? So first we write down what we know. So big N, or the number of particles, is 1.0204 times 10 to the 24 particles. Avogadro's number, always the same, 6.02 times 10 to the 23. We write down our formula and make little n, or the number of mole, the subject. So little n is n over Na. Then we can substitute our numbers in. So big N is 1.0204 times 10 to the 24 over Avogadro's constant, and we get 2 mole as our answer.